So let's talk about how to draw a kmap if we have 4 variables. Let's remind ourselves pretty quickly of the rules. The first rule is that when I am grouping them together or drawing rectangles over top of the groups, each rectangle has to cover a binary number of 1s. The second rule is the rectangles have to be as large as possible, so I want to group as many as possible because I want there to be as few groups as possible. And when I group them together, I cannot group them diagonally. They have to be grouped either vertically or horizontally. The rectangles or the groups can overlap, so a single one can be in multiple groups, and the rectangles can wrap around the edges. This last rule is going to apply a lot more if we have a 3 or a 4 variable Karnaugh map. So let's try it out. Now there does come a point in time when using a Karnaugh map to try to simplify the minterms on a truth table is no longer efficient, but it can be very efficient for a truth table that has 4 variables. So I'm going to draw a truth table with 4 variables, but I don't want to draw 32 rows. So I am only going to draw the rows that have minterms or 1s in the output column. Alright, so here is an example of a 4 variable truth table where I have only pulled out those rows that have generated a minterm. And there are 8 of them. So the next thing I'm going to do is write down the minterms that these 8 rows are generating. So now I'm going to draw a Karnaugh map. Once again, it's still a 2-dimensional Excel spreadsheet, but this time I need 4 variables. So the rows are going to represent 2 variables, and each one of the columns are going to represent 2 variables. So let's put X and Y down the rows. There'll be 4 combinations of X and Y, so I'm going to have 4 rows. As I draw each one of the representations of the X, Y, remember I can only toggle one of the 2 variables at a time. So the first time I'm going to write XY, then I'll toggle the X to X naught, and then I'm going to leave the X naught the same and I'll toggle the Y, and then I'm going to leave the Y the same and I'm going to toggle the X. So I should have all 4 representations of X and Y. I'm going to put the Z and the W together across the top. Once again, when I do that, I can only toggle one of the 2 variables at the time. So I'll toggle Z, and then I am going to leave Z naught the same and I'll toggle the W, and then I'm going to leave the W naught the same and I will toggle the Z. If you toggle both of them simultaneously, for instance, if I went from ZW to Z naught W naught, it would throw off the value of my Karnaugh map. Alright, so now that I have my Karnaugh map drawn, there are 16 squares. I'm going to map each one of these 8 minterms into its corresponding cell. So this one is going to be on row XY, and then I'm going to find ZW and put a 1 in there. This one is also on XY, so I'm going to find Z naught W naught. This one is also on XY. I'm going to find ZW naught. This one is on XY naught, which is right here. XY naught is this row, and then I'm going to find ZW. This one is also on XY naught, so I'm going to find Z naught W naught and put a 1 there. This one is also on XY naught, so I'll put a Z W naught. And then this one is on X naught Y. Well, I'm pretty sure that this is X naught Y. And then I'm trying to find the Z W naught, which is right here. And then this one is on X naught Y naught, which is right here. And I'm looking for, again, Z W naught. So if I have 8 minterms, I should also have 8 1s on my Karnaugh map. Now the next thing that I'm going to do is I'm going to group them together, remembering my grouping rules. So the most obvious grouping is right here with this large group of 1s. I am going to make that blue. Now I see that there is another group of 2 1s right here, but if you remember, I have 2 1s right here, but you remember I said that I can wrap around. And so if you'll notice, these 2 could actually wrap around in order to generate a group of 4. I can see that I haven't grouped all of them together yet, and so there is a 1 right here, but I could wrap it to this corner, and I could wrap to this corner, and I could finally wrap to this corner. The reason why we can wrap around the corners is because I can order the variables along my Karnaugh map any way that I'd like to. I could have put the x's and the z's together and the y's and the w's together. I could have started with z naught w naught instead of starting with zw. So the way that I order the individual variables on my Karnaugh map are going to determine what it looks like when it's finally grouped together. This is the reason why I can group these four together on the corners, because if I had ordered them separately, there's a very good chance that they would have been side by side already. So I have three groups, a blue group, a green group, and a red group. Let's see if we can move through the groups to simplify my Boolean expression. Let's start with group 1, which is the blue group. If I move vertically through the rows, I can see that the xy, you can see both the x is changing and the y is changing. So there is nothing that's remaining the same as I move down all four of the rows. But if I move across the column, well, there's only one, so I can see that the ZW naught is not changing. So now let's look at the green group. All right, the green group, which is group 2, remember I have to group them as large as possible and we can wrap. And so my green group are the two on the bottom down here, but also the two across the top. So once again, as I move vertically from this row to this row to this row, the value that I see that is not changing is the x. I can see that on this row and this row the x is the same, but the y is toggling from y to y naught. So if the x is not changing, I'm going to write that down. Next, I'm going to move horizontally across the two columns. Maybe I should draw it up here. As I move horizontally across the two columns, I see that my w naught is remaining the same. I see that I am toggling z's, but the w naught is remaining the same. So let's look at our last group, the red one. So if I'm going to move through my red group vertically, I'm going to move from this row to this row to this row to this row, and the value that I see that is not changing there is the x. I can see the x is remaining the same and the y is toggling between y and y naught. If I move horizontally across the two columns from this one to this one, the value that is not changing is the z. I can see that the w is toggling back and forth between the two. So now I have mapped out and grouped and simplified my three groupings. So the next thing that I'm going to do is, just like I have the sum of the products, I'm going to add the three of them together, and we're going to end up with zw naught plus xw naught plus xz. As I said, I may not have the most simplified of the Boolean expressions, but I am significantly farther than the 8 min terms that I would have generated here. See, we could either factor out the w naught, or I see that we could also factor out z. We could also factor out the x's. There are some common values among these. I'm going to leave this expression here as the f of x, y, z, and w. This is the Boolean expression that is generating this output statement on a truth table that has 32 rows on it.